You're good.
Okay. This is lesson 21, and we're starting a new unit. This unit is on logic, digital logic, and my plan at the moment is to have 3 lessons, which is significantly fewer than the 6 that I had thought about. But at the moment I think we will just plan on 3 lessons. This first lesson, lesson 21, is on logic gates, and this one is all pencil and paper, so I'm going to be writing a lot of stuff on the board. The next 2 we will actually use the oscilloscope and the circuit board, but we won't worry about that till we get to those. Now, in the digital logic, we need to look at 2 states. Generally, all of the logic has or is written in terms of 2 states. So there are several different groups of 2 that we can think about. One of them is using ones and zeros, and if you're familiar with binary counting and things in computers, those use the ones and zeros. We can also think of true and false, because that's 2 states. And then we can also think of high and low. The high and low will be relevant when we start with the circuit board, because we have the diodes, and a low voltage means that the diode is off, and a high voltage means that it's on. So we're going to be looking at those, but not till later. So in this lesson, we're going to look at a lot of things with ones and zeros. So there are 6 logic gates. I'm going to show you the symbols, and then we're going to look at what's called a truth table. So in the truth table, we think of all the possible inputs and figure out what the output is to go with each of those. And so that'll make more sense when we start looking at this. Now, on these I have the truth table there, but you have to fill it out. And since it's hard for me to do diagrams, it's easier to just draw them on the board. So you will need to draw all of these diagrams on the printout. So if you haven't printed this out, you need to print it out. Okay. So on the second page, we're going to look at the symbols and the truth tables of the 6 logic gates. Well, the first one we're going to look at is AND. And these are generally written with capital letters. I'm not going to underline it here because then you may think it needs to be underlined. But I did underline it to sort of distinguish it from one logic gate to the other. So it says draw the symbol for an AND gate. So the symbol is sort of a rounded thing out to the front, a straight line here, and then 2 lines out to the left. You read this from left to right. So here is A and here is B. And then over here we have the output. So I think what I'm going to do is put the truth table underneath. Okay? So for A and B and out, we have these various possibilities. If we have zeros and ones, then we're going to look at the possible combinations that we can have for A and B. And it works best if you do this in a logical progression. You don't want to just randomly see if you can think of all the combinations. So generally we start out with 0, 0. And then the next one, I usually keep 0 first and then a 1. Then we can change this to a 1 and a 0. And then our last combination is 1 and 1. And on the pages, I have a table that has all these outlined, and so you have boxes. Okay? Now, you need to know what the rule is. And some of these are very logical. Some you have to think about for a little bit. But and, so that means something and something. So we are actually looking for, you might think of 0 is nothing, 1 is something. So 0 and 0 will still give you 0. You still don't have anything. Now, for 0 and 1, well, you need both of these to be the same. So if both of these are the same, then you have something. If one of them isn't, then you don't. So it says the rule is if A and B are both 1, the output is 1. Otherwise, the output is 0. So a 0 and a 1 is 0. And of course, 1 and 0 is also 0. 1 and 1 is a 1. Okay? Now, we're going to look at the OR. So we're going to put OR, and the OR gate looks different. It looks different in 2 ways. Instead of a straight line, it has a curve, and instead of a rounded end here, it kind of comes out to a point from both directions. Now, when you're looking at what I've drawn, sometimes it may not be obvious whether this was a point or whether it's rounded, but what should tell you definitely is this left side. Okay? So again, we have 2 inputs, an A and a B, and over here is our output. So our truth table is the same sort of thing, A, B, out, 0, 0, 0, 1, 1, 0, and 1, 1. Okay? So the rule is that if either A or B is 1, or if they're both 1, then you have a 1. Well, we've got 0 and 0, so that will still be 0. If you have 0 with a 1, if either one of these is a 1, which it is, then our output is a 1. And this is the same thing here. Now both of these happen to be 1, and that's still okay. So we end up with a 1 there. Okay? So that's the AND gate, and then the OR gate. Then we have a NOT. So the gate looks like this. It has a little circle, and it has a triangle, and then this is the out. Notice that it has only 1 input. And what we're going to see in a minute is that we can combine the NOT gate with an AND or with an OR, and then we shorten the symbol, and we'll show you that. Okay? So here we only call this an A. So we have A and out. Well, there are only 2 choices. A can be 0 or A can be 1. And the rule is that I just wrote it. If A is 1, the output is 0. If A is 0, the output is 1. You can also call it invert. So if A is 0, if you invert that, now this is not the invert like 1 divided by. It's a switch, or I guess switch it to the other number, or the opposite. So if we have a 0 here, then if it's not a 0, then it's a 1. You can also think of it that way. So here we have a 1. Well, we want not a 1, and the only other choice we have is 0. So that one is a little bit shorter. Okay. Now we're going to look at what is called NAND, N-A-N-D. And I think I I'm going to do this. Because if you have two inputs, this set of inputs is always going to be this. So 0, 0, 0, 1, 1, 0, 1, 1. It's just the output that's going to be different. So if I put a NAND, it's called NAND, and what that is not AND. So basically, you would do the AND operation, and then you would do the NOT. So whatever you would get with AND, then you would invert that to the other number. Now, how do we put this here? Well, we could use the AND symbol and this NOT symbol, but that makes things a little bit bigger than we want. So what we would like to do is a shortened version. The way to shorten it is to take the circle. So we want to use the circle after we have done the AND. So we're going to put the circle over here. Okay? So the AND with the circle afterwards is a NAND. Okay? So now, if you think about this, if it's not AND, what you should end up doing, or should end up with, is whatever you had here for the AND, you just put the other one there. But we might go through this. Okay, 0, 0 with the AND would be a 0, with the NOT would turn it into a 1. So 0 and 1 with AND, you need both of them to be the same, or you get 0. So that's a 0. This is a NOT, so it's the other way. And these two give you the same result. Now, 1 and 1, the AND gate itself would give you a 1, but the NOT tells you that it's 0. So if you look back at where you had AND, you'll see that it's 0, 0, 0, and 1. It's just the opposite of that. Okay? Now, we can do the same thing for the OR. So instead of OR, we're going to have NOR, and that's not OR. And the way we draw that symbol is the OR gate with a circle. And most of the time you don't really have those little lines through there. You have the open circle. So I'm going to erase the output. The input is the same. If you have two inputs, this is the set of input numbers combinations that you will have. It doesn't matter what else you have. Okay? So if we look at 0, 0, OR, that's a 0. And then this makes it the opposite of that. So this is going to be 1. So 0 with a 1, you have the one or the other is a 1. So the OR would be 1, but the NOT would make it 0. And the same thing for here. And then 1 with the OR is 1, but with the NOT makes it 0. Okay. Now, after you think about all of these, it looks like we're getting a lot of different things. And you may wonder, well, how do I keep track of everything? Well, after you work with it a little bit, you'll get used to it. So there's one more gate. Remember, we did the 3, and then we revised this one and this one, so that's 5. Now we have one more gate. And if we look back to when we had the OR, it was either of these or both of them. If either of these was a 1 or if both was a 1, then that was okay. But what we might want is if either of these is a 1, then we'll keep that, but we don't want them both being 1s. So this is what's called an exclusive OR. And it's represented by XOR. So that's exclusive OR. And if you think about it, it really does mean one or the other. If you have both, then you don't want that. So the symbol should look something like an OR, and it does. So we'll start out by drawing that. I have this. But then we put an extra curved line here at the beginning. It's not attached to that, it's just sort of there in front of it. And then we have our A and B. Oh, we need our output over here. Okay. So we'll start with our truth table, A, B, out. We'll write our possibilities for the input. So it's always 0, 0, 0, 1, 1, 0, 1, 1. Okay? Now, with a 0, 0, we don't have anything, so we're still getting 0. 0 or 1. Now, notice that it's just one of these that's a 1. So that's what this means. That means it's okay. So we get a 1. And the same thing for this. But when we get here, we notice that both of them are a 1, and that does not fit our rule for the exclusive OR. So this is going to be a 0. Okay, so those are our 6 gates, and it's kind of interesting that you can make some combinations of various gates and get a different one. This concept of completeness means that you can take one gate, and we're going to look at the NAND gate. You can take several of these NAND gates and put them together in particular ways and end up producing an AND, a NOR, or exclusive OR. You can get all of the rest of them. You can actually do that with any of, well, it says with any of the gates. I'm not sure about the NOT gate, but we're not going to look at all the possible combinations, but we are going to look at a NAND gate, which is this one, and see how we can put those together, to put several of these together to produce the other gates. Now, you may wonder, why would you want to do that? Well, it turns out that producing a NAND gate with transistors, and that's kind of the whole idea for this, is we want these various logic gates so that we can make them out of the transistors. We aren't going to do that, but that's what's actually done. So NAND gates are very simple to make with transistors. So if you have a bunch of those around, you can put them together to get the other things. So from the electronic point of view, it's fairly simple to have a bunch of these, and then it doesn't matter what kind of gate you want, you can put them together to get the thing that you actually need. So this is on page 176. I'm going to I think I'm going to leave this here, the NAND gate, so that we can look at it and see without having to remember when we're working through some of the others. So I'm going to erase the rest of this. And then what I'm going to do is show you, and this will also give you some practice at how you use and figure out the truth tables, because that's basically what the homework is going to be, is to look at a combination of these different gates and figure out the truth table. So I'll show you some of those examples though. Okay, so I'm going to do a NOT. NOT is pretty easy to do. And on the way through some of these, there's some ways of drawing the input and lines that, some things you have to know in order to be able to figure out the truth tables. So we're going to start with one NAND gate. There's a little circle here and the output here. Okay? Now, a NAND gate has to have two inputs. But with a NOT, remember we only had one input. So we had a 0 or a 1. So if we only have one input here, how do we get two up there? Well, we draw it this way. Okay, so we put A here. So what this means is that whatever we have for A goes to the top side as well as the bottom side of the NAND gate. So instead of putting, I guess we could have drawn a line up here and a line down here and then put A and A. So like here we could have put A and A, but that's not the standard way it's done. The standard way is to do it like this. So if we put in a 0, we have a 0 here and a 0 here. So if we look over here at our NAND gate table, 0 and 0 gives us a 1. So if we put in 0, we get out a 1. Then if we look at 1, we put in a 1 here. So that means we have a 1 up here and a 1 down here. So we have 1 and 1, and that gives our output as 0. So we have a 0. Now, if you look back at the NOT table when we talked about it originally, you'll find that this is exactly what we had. So what we're doing is we're going through and showing you how you can get these other gates by using a combination of NAND gates. Now, I will never ask you, well, I guess if I ask you to write these like on a test or on something, you have this information available. But I would never ask you to just from memory figure out what combination of NAND gates would give you any of the others. And actually, there were some in this book, and I looked up a couple of the others because I tried figuring them out, and they're not that easy to figure out if you don't already know what the combination is. Okay, so now we're going to do an AND. So where we're headed is to get a truth table for a combination of NAND gates here that will give us the truth table for AND. Okay? So that one, let's see, I'm going to draw that here. We start with a NAND. Remember, we're only using NANDs. And we need two inputs, so we are going to have an A and a B. And then this comes out and it splits. I'm not sure if split is the right word. Let's say it goes both directions. So we have another NAND and then an output. Okay? So we're going to look at our truth table, A, B, out. And this is a little bit smaller, but 0, 0, 0, 1, 1, 0, 1, 1. So that's the standard, that's all the possible combinations of 0 and 1 if you have two variables. So, we're going to look through this. And I'm going to make sure that I do it correctly. So, if we're starting out with 0, 0, we have 0, 0 here. Now, what happens, what's the output of our first NAND? Okay, 0, 0 is a 1. Okay, so a 1 comes over here and it goes both directions. So we have a 1 and a 1. If we look at our NAND table, 0 or 1, 1 gives us 0. So this is a 0. Okay? So we have 0 and 1. So 0, 1 gives you a 1. This 1 goes here, goes both directions. So 1, 1 gives you 0. Now this is a 1 and a 0, so it turns out to be the same thing as the one right above it. So now then we have 1 and 1. Okay, 1 and 1 gives us a 0. So then we have 0 here. 0 goes both directions. So we have 0, 0, and then our output is a 1. Okay. So again, this is, if you look back to the AND table or AND gate that we did originally, this is the same truth table that we had for that one. Okay. So we're going to look at some more. And you may need to kind of think about this slowly, or so if you get very confused during some of this, you might want to turn this off and go think about something else for a little bit and then come back. But once you kind of get used to thinking about the ones and zeros, and if you have a table to go by, then it's really pretty easy. Okay, so we're going to do an OR. Now this one's a little more complicated. So we have a NAND and another NAND, and both of these have double inputs. So we have A, B, and then the outputs of these two go over to another NAND. Okay? So we're going to have our A and B out. So we have 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now, what I would recommend perhaps on some of these, especially the ones that you have to do, because I'm not doing all of these, I will in this section, but when you have to do things to do a truth table, what might work well is to very carefully, neatly, with a pen, and I normally don't recommend a pen, but this time would be acceptable, is to draw the gate with a set of gates that I will have up here, and then with a pencil for each of the rows, each of the combinations, to go through and write down the ones or zeros until you get an output. And then, if you've done it neatly in pencil, and don't write too hard with a pencil, then you can erase those and then do your next row. There are some in a little bit that are going to have 3 inputs, an A, B, and a C. And we'll see that when we have 3 inputs, we have 8 possible combinations. So it's going to be easier if you can write down some of these things as you go work through the problem rather than trying to remember everything all at the same time. Okay, so here, and actually I might just do that. Since these others weren't that complicated, but here we've got something up here and something here, and then we've got 2 inputs there and 2 inputs there. So I'll show you what I mean by writing down the results as we go. Okay, so this is a 0, 0 here. So we would have a 0 here, a 0 here, and we could go ahead with the B. B is 0 and 0. Okay? So now we go back to our NAND table, and it's very convenient to have this around. So our NAND table with 0, 0 is a 1. So this is a 1, and this is a 1. Now, these two ones go to this NAND. So we go down here to 1 and 1, and the output is 0. So this is a 0. Okay. So once you figure that out, then you can put your answer there. Okay. Now, I'm going to erase those. So that's what you would do if you had drawn the NAND gate or the gates in the 1. And on the second line, and that is indeed what I arrived at before. As I said, I did all of these on scratch paper, so I just wrote the results, so I don't have all my intermediate steps. Well, let's maybe do one more of these. Okay, we already did that one. I'm going to erase all of these things. And let's try this one. Because you see, here I had 0, 0, 1, and here I've got 1, 1, 0. So you might think, well, if I switch everything, I should end up with something different. Well, maybe not. Okay, so A is a 1, so that's a 1. B is 1, so we have a 1 there, that comes down here. C is 0, so we have a 0 here. Okay, 1 with an AND is a 1. 1 and 0 with a NAND, there's my NAND, 1 and 0 is a 1. Now with my OR, a 1 and 1 with an OR is a 1. Okay? So my answer here is also a 1. So you can't necessarily say, well, if I switch all of these to get this, then I'll switch my output. So that doesn't work. You have to go through all of those. Okay, so now let's go to 179. We're going to look at 179 and 180. I'm going to draw the logic gates, and I'll do one of the steps for each of those. And there's a couple of other features in drawing these things that I want to point out. Okay? And actually this next one is simple enough. I'm going to just go ahead and draw it over here. So this is in the homework, page 179. The first one is an OR gate, has input A and B, and that output goes over here. Oh, yeah, there's one more thing to talk about. C, and then a line out there for the output. Okay, you notice that the OR gate looks familiar, A and B, it has two inputs, it has one output, this comes down here to an AND gate, but we have the little circle in front instead of after the AND. So the circle means not. So whatever C is, then whatever gets here is not that. Okay? So I'm going to go ahead, actually I'm not going to draw all of these because for A, B, and C you have this combination and you just have that all the time. So what I'm going to do is a 0, 1, 0. Okay. So let's see how we do that. Okay, A is 0, I'll put a 0 there. B is 1, I'll put a 1 there. C is 0, but what you put over here, what goes into this is a 1. and I think I'll put it kind of down here. I'm not sure I really want to put it back here because then you might think you still have to take the opposite of it. So if C is 0, then not 0 is a 1. Okay, we go to A and B with the OR gate, so we have 0 and 1. 0 and 1 with OR is a 1. So now with an AND, we have 1 and 1. With our AND, we have 1 and 1, which is a 1. So our result, our output for this one is a 1. Okay, which agrees with what I had before. So on this, the homework, now it's up to you, and actually these others in the lab part, you have to go through and finish filling out, figuring out the truth table. Okay, on page 180, there are 3 of them there, so I'm going to draw those and do one of the sets, and then I'll be done, and then you can work on these. Okay, so at the top of the page, we have 3 inputs. We're going to have an AND, so we have an A and a B. And then we have a NAND, and we have a junction here from this B down to here. This looks similar to one of the others, but it's a little bit different. How is it different? I hope it's different than the other one. That's different than that one. I know what I need to do. Yeah, let's make this one an AND. Okay, this is exactly what I had on my other paper, but on my other paper I didn't draw the OR gate properly. It was half OR and half AND. So when I did it on the board, I did it as an OR gate. So now we're going to make this one as an AND gate. So anyway, we'll come out here and out here, and I'll just draw this kind of like this, and we're going to make this another AND gate. Okay. So since this isn't going to match what I have on here, let's just do something here. So we'll have A, B, C out. Let's do a 1, 0, 1. Okay. So if A is 1, this is a 1. B is 0, this is a 0. This also goes down to here, which is a 0. C is 1. So up here, 1 and 0 with AND. 1 and 0 with AND is 0. 0 and 1 with NAND is a 1. And then we have 0 and 1 again with an AND. 0 and 1 with an AND is a 0. Okay. So this output will give you a 0. And then of course it's up to you to go through and finish filling out the table. Okay, this next one, the one that's in the middle, I'm going to draw over here. It's even more complicated, but it does show several features. So we're going to start with a line. Oh, actually it goes along over here a little ways. And we have it down and over, and this is going to be an AND. Then we have a circle here for a NOT. And this comes all the way over here. This is B, this is A. Then down here, we're going to put an OR, like this. And we're going to use a feature that we've used before. So from B down to here. So it means whatever goes in for B also goes down to here. Now, for our other one here, we're going to come from A. So I'm going to put a dot up there for A. Then, when we get to the line for B, we have to indicate that it's not a junction, we're jumping over it. And the standard way to do that is to put a little curve like this. And in fact, that's actually done in electric circuits, and I was kind of remembering when I was looking at this, I probably should have done one of those in that, the diode bridge, the 4 diodes, because a couple of people thought that 2 lines that crossed was an actual junction when it really wasn't. But anyway, this means it's not connected. So this comes down here and goes over to there. And then we have this output here. And then we have C. C comes along here. And this is a knot. Put a circle there. Let's see here. And then this comes over here. And we have an OR gate. It's OR, and then we have our output. Okay, that one, that goes up there, that's there, and that's there. Okay, so we have our same set of zeros and ones, the 8 of them, and I'm going to pick one of them and do it. Let's see which one I have here. I have done a 1, 0, 0. Okay, see if we can go through this and get the same thing twice. Okay, A is 1. So this is a 1 that goes over to here. It also goes on this line down here to over here. So that's a 1. B is 0. 0 goes across here, but the circle means not. So not 0 means a 1, and I'm going to put it underneath there. Let's see, B is 0, comes down to here, so we have a 0 there. C is 0, so it goes here, but the circle means not. So not 0 is 1. Okay? Now, we can actually do this one up here. This is an AND gate. The circle in front of it has nothing to do with the output over there. So we have 1 and 1 for AND. So this is a 1. Now here we have an OR gate. We have 0 and 1. 0 and 1 for OR is a 1. And then this comes down to here. So we have an AND with a 1 and a 1. A 1 and a 1 for AND gives us a 1. And then for OR, 1 and 1 gives us a 1. Okay? And that is indeed what I ended up with earlier. So we have our output is a 1. Okay? So that's the second one. And then the last one only has 2 inputs, but it's a little bit more complicated as far as drawing it. And it does have an exclusive OR, which I didn't have in any of the others. So this is the last one on page 180. We have a line here, and we have an AND with a not in front of this one. This is over here and down. And then here we're going to have an exclusive OR. So we have the OR with an extra line in front of it. Oh, let's see. So this comes here out to here. This comes out. It goes up and it jumps that one and goes up to the top, where there's a junction there and a junction here. This is A, this is B. So I have all of that. Then these 2 outputs come here to a NOR. So we have our OR, but we have the circle after it. Okay, so it looks a little more complicated, and it kind of is, but it still only has two inputs because the two of them actually go to more than one place. So we have our A, B out, and let's see, let's do, oh, we might as well just do the first one, 0, 0, and see what we end up with. Because I actually did all of these. Okay, we'll start out with A is 0, so that goes over here. A also goes down here to this one, well, that's 0. B is 0, so B goes across here to 0. It also goes here and up here to this one, but this not means that it's not 0, so it's a 1, so I'll put it underneath there. Then we can look at our AND gate with 0 and 1. AND with 0 and 1 is a 0. Then here we want to look at our exclusive OR. Find my exclusive OR, and we need a 0, 0, so that's still 0. Then we have 0, 0 with a NOR gate. So we find our NOR, where's my NOR? There's my NOR. 0, 0 with NOR is a 1. So our output then is a 1, and that's what I had got earlier. Okay. So the main thing is that you want to go through and basically kind of understand the gates and their outputs, get practice at using these, and by the time you fill out all the stuff that I didn't do on the board, you will have quite a bit of practice. So I would make sure that you have the first 6 gates available so that you don't have to really think through them anymore. You know, if you want to, that's certainly fine, but it's a lot easier to just look at what you have here and then look at the table for the symbol and see what the output is, and then that just goes on to the other one. Okay, I think we're done with this, and the next one will not be such mathematical kind of thing. It will actually be working on the circuit board. And then use light pencil to draw all those, and then you can erase them easily. If you've drawn the gates in pencil, then when you're erasing these other things, you erase part of the gate. So if you have these in ink, then you can just use an eraser and erase over the whole thing. Okay, so the next one, we have a 0 and a 1. So a 0 for the A means that we're going to have a 0 in both of those places. Here we have a 1, we're going to have a 1 in both of those places. So back to our NAND, with 0, 0, we have a 1. And with 1, 1, we have a 0. Let's see if I can remember that till I get over here. So that's a 1, and this is a 0. Now, we have a 1 and a 0 going into a NAND. And it really doesn't matter. Notice here, if you have 0, 1 or 1, 0, you still end up with the same result over here. So let's just say the top one is this one and the bottom one is this one. So we have 1, 0 gives us a 1. So our output is a 1. Okay. And if you look back at the OR, the original OR that we were doing, you'll find that this is correct so far. Now, with a 1 and a 0, is that going to be any different than what we have up there? Well, we'll put ones up here and zeros here. But if we put ones up here, we're going to get a 0 there. And put zeros here, we're going to get a 1 here. So we're still going to end up with a 1 and a 0, which is going to give us a 1. So that answer is going to be the same thing. Okay. Now, let's look at the bottom one. Okay. We already have ones and ones, or 1 and a 1 here. So let's change this and put a 1 and a 1. So 1 and 1 is 0. So up here 1 and 1 is 0. Now, what does 0 and 0 give us? So 0, 0 gives us a 1. So this is a 1. And if you look at the OR gate, this is the same as the truth table that we had before for the OR gate. Okay, let's see. We have 2 more of these. We have a NOR. So let's see. I think I'll just erase this part here in the middle. Now, it's a little bit more complicated. And actually, I'm going to need some of this space, so I'm just going to erase this one as well. Okay. So the next one is NOR. And as I was saying, it's not that easy to figure out what combination to use to get these, so I will never ask you to do that. I think people just had to play around with these for a while until they figured it out. Okay, so we're going to start with a NAND and another NAND. Okay, this one has double input. This one also has double input. So the A goes to both inputs, the B goes to both inputs. I don't really like the word that I used earlier. I said split. There's nothing that's really split. It's that this goes to both places. I suppose we could have drawn 2 lines and put a B with each of the lines, but again, that's not the standard way to draw them. Okay, so when this comes out and this comes out, we put both of those into a NAND, and that looks similar to, that looks like our OR gate that I had over there. So now we want a NOR, so what we're going to do is to take that and put it into another NAND gate. Okay? So we're going to have our A, B, and our output 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now I'm going to do the same thing about writing these on here as we go. So if we have 0 and 0, with B we also have 0 and 0. So from our NAND gate, 0, 0 gives us a 1. So this is going to be a 1 and this is a 1. Now we have a 1 and a 1 that goes in, and we have 0 coming out. So this is a 0. Now here 0 goes to both of these, so again we have a 0, 0, which is a 1. And if we look at our NOR gate, we find that our 0, 0 gave us a 1. Okay, so that's right. For the next one, our A is going to be 0. So I'm going to leave the 0, 0 and the 1 there. I'm going to erase the others and work through that. So for B, we have a 1 and a 1. 1 and 1 gives us 0. So now we have 0 and 1. Let's say that the A is 1 and the B is 0. So 1 and 0 gives us a 1 here. This 1 goes to both of those. So 1 with 1 gives us a 0. So, I don't want the red there. This gives us a 0. Okay? And that's what we had in the NOR gate. Now, if we switch and have the A is 1 and the B is 0, we can tell that since it's symmetric, that we're going to get exactly the same thing. So I'm not going to actually write that one up there. Okay, so this will be 0. Now we have 1 and 1. So I need to change this. I'll change these. Change that. Okay. So I will put my 1 and 1. Since 1 with 1 gives us 0, we'll do that. Then we look back over here. 0 with 0 gives us 1. So this is a 1. The 1 goes to both places. So 1 with 1 gives us a 0, and we have an output of 0. So we can put our 0 here. And if you look back to the NOR gate, when we did the NOR to begin with, you'll see that this is the truth table that we got. Now, we have one more of these to show you. And it does show another feature of how things are drawn. So it's going to take even more, a little bit more space, so I'm going to erase this. Okay. So this is the exclusive OR, the XOR. Okay, so I'm going to draw a line down here, put a NAND, and then this is our A input. Then from here, I'm going to come down and over with a NAND. Notice that I've put a dot there. I put a dot there to mean that those two lines are actually joined together if you were making a circuit. It means that the value of A goes over here to this NAND, and that same value comes down to this other NAND. And then we have something similar down here. This goes over, we have a NAND, that touches there, so that's joined. This is B. Okay, now then this comes out and goes to both of these NAND gates. Again, it's not split, it goes to both. Then the output here comes down, and this output, and we have another NAND. Okay. So that one's probably the most complicated of all of them. But the other feature is that if you have something that needs to go to one of these and then up here to another, then you just put a dot there to show that that's a junction. Okay. So again, we have our A, B, out, 0, 0, 0, 1, 1, 0, 1, 1. Okay. So now we get to go through, and this is where you probably really should, something this complicated, you really should write things out, or else draw it on another piece of paper and write on there, because trying to keep track of these things in your head, I don't know, all of you are a lot younger than I am, so you might be able to do that easily, but I just didn't want to try that. Okay, so we're going to start with A is 0, so A being 0 means that that goes over to here. It also comes down to this one, is 0. Okay. Now B is also 0, so it goes all the way over here to this, and it goes up here to this one. Well, you notice that we can't do anything with these yet because we don't have the other input. So we have to look at the first NAND gate. So 0, 0 gives us a 1. So we put a 1 here, and that 1 goes to both of these places. Now, we have 0, 1 or 1, 0. Both of these give us a 1. So this is going to be a 1. This is going to be a 1. Then we look down here. 1 with 1 is 0. So that's a 1. I'll put it in there. So our output is 0. Okay? And that's why I recommend that you have the truth table of the NAND. You don't really want to have to stop and think through each time you have one of these NAND gates. It's enough that you think through it to begin with to get a truth table. Then once you've got the truth table, then you make use of it. Okay, so our 0, 0 input gave us a 0 for output. Okay. Now we're going to, well, I think I'm just going to erase everything. Because sometimes if you only erase a few things, then you don't know whether you've erased everything that you needed to or whether it's still there. Okay. We are going to notice, though, that this is symmetric, so if I flipped this or if I interchanged A and B, I would still have the same diagram. So when we do 0 and 1, we're going to have the same result as if we do 1 and 0. So I'll do the 0, 1. A is 0, goes over here to 0. It comes down to here. And then B is 1, so B goes over to here for 1, it goes up to here for 1. Now, we have 0 and 1, and again it doesn't matter whether we have 0, 1 or 1, 0. We still end up with the output is a 1. So this is 1, that goes up to here and down to here. So at the top we have a 0 and a 1, which is a 1. Down here we have, though, a 1 and a 1, which is a 0. Okay, so those go over here. Now we have a 1 and a 0, so we end up with a 1. And if you look back to the exclusive OR, the 0 and 1 was a 1. Also, as I mentioned, since this is symmetric, it doesn't matter whether we had the A as the 0 and the B as 1, or the A as 1 and the B as 0. We would end up with the same thing, so I will just put that over here. Okay, now we have 1 and 1. Okay, so I'm going to, actually, this one and this one is the only one I'm going to leave. Okay, so A and B both are 1. So B is a 1 that goes here, a 1 that goes here. A is a 1 that goes here, and it also goes here. So if we look here, 1 and 1 gives us a 0. That 0 goes up here, that 0 goes down here. Now we have a 1 and a 0 and a 0 and a 1. As I said, it doesn't matter which you have one of each. The result is a 1. So we have 1 there and 1 there. Then we look down here for the 1 with a 1 gives us a 0. So our output is 0. And our output is 0 here. And again, if you look back to the exclusive OR, this output column is the same as what we had when we did it originally based on the original definitions. Okay, so that takes us through the basics of the logic gates. Now, the next thing we're going to look at is I would say not random combinations, but I've picked out a few combinations. I think a couple of them I actually just made up, and there's a couple of them that I found in a book. There's also one that you have to make up the logic gates for, and I'll talk about that in just a minute. But let's look on 177 part 4. It says combinations of logic gates. So what I'm going to do, since we're not using the NAND exclusively, I am going to erase everything. Now, what I would recommend is that you find the first couple of pages, because that's what I'm going to do, so that you have your AND, OR, NOT, NAND, NOR, and exclusive OR. The 6 logic gates, so that we have access to those, so you don't really have to think through those. It's like you've already figured it out once, so you don't need to figure it out again. Okay, so on these, you're going to have to draw the logic gates, because as I mentioned before, it's complicated for me to get these diagrams on here, so I'm just going to draw them and then you draw them. Okay, so this is part 4 at the bottom of page 177. So we're going to have a NAND, and as I said, some of these, they're just made up, and some I found in a book, and at the moment, most of these you don't know what they represent, and that's okay. We're just doing the logic of it. It's kind of like when you add 2 and 2 in arithmetic. You don't really need to know 2 watts plus 2 watts. It's just 2 and 2. So here we're going to have an AND gate with a single input out here. I'm going to have an OR gate. Remember, it's just a regular OR. It's not the exclusive, because it doesn't have that. So we have this out here. It has to have 2 inputs. Then we're going to take the input of both of these and put them into a NAND. Okay. And since we have 2 inputs, we're going to have the same kind of looking thing for the truth table. We have A and B, so it's always 0, 0, 0, 1, 1, 0, and 1, 1. Okay. Now, since this has different kinds of gates, this is where it's even more beneficial to draw the set in ink and then use a pencil to go through to figure out each of these. Okay, so our A is 0. Again, remember, this means that both of these things get put to 0. B is 0, so these are both 0. Okay. Then we look at 0, 0 with an AND with 0, 0 is 0. Now we have 0, 0 with OR. Okay, 0, 0 with OR is also 0. Then we have 0, 0 with NAND. So we have to find our NAND gate. 0, 0 with NAND is a 1. So we have a 1 there. So we will put a 1 here. Okay, now we're going to do the same thing. Now, if you notice, this picture is not symmetric. It has something up here and something down here, but these 2 gates are different. So our 0, 1 is not necessarily going to give us the same thing as 1, 0. So we are going to have to do these individually. Okay, A is 0, so I'm going to leave that part of it. And B is 1, so we have 1 with a 1. Now if we look at our OR gate, 1 with a 1 gives us a 1. And then with our NAND gate, a 0 and a 1. And with NAND it doesn't matter which one is 0 and which one is 1. You've got one of each. So our NAND gate with a 0 and a 1 is a 1. Okay? So we have a 1. And this gives us a 1. So, and I've been checking, when I worked all these out and I have them here, I'm making sure that I end up with the same thing. So, I remember I said that since this is not symmetric, a 1, 0 will not give you the same, not necessarily give you the same thing as 0, 1. So we're going to have to check that and see what we get. So we need to erase all of these. And our A is a 1, so 1 goes to both places. B is 0, so 0 goes to both places. So our AND gate with 1 and 1, AND with 1 and 1 is a 1. Our OR gate, OR with a 0 and 0 is a 0. Then our NAND gate with a 1 and 0 is a 1. Okay, let me check this. A, we have 1 and 1 with an AND. 1 and 1 with an AND is a 1. And 0, 0 with an OR should be a 0. 0, 0 with an OR is a 0. So 1 and 0 with our NAND should be a 1. What if I did that? Yeah, that should be 0, 1. This should be a 1. And so that's not what I have on my paper. So I must have looked up something wrong. Okay, let's try the 1 with a 1. Okay, I'm going to erase that and that and that. So with A as a 1 and a 1 and a 1 gives us a 1. With the OR, our 1 with a 1 gives us a 1 also. And then our NAND with 1 and 1 gives us 0. So we have a 0 over here. Okay? So that's basically how you do all of these things. Now on page 178, you have to figure out how to set up the gates. It has to do with a doctor needs to prescribe medication. There's 3 possibilities, but 2 of them, they cannot take both of them at the same time. They can take one or the other, but not both, because they interact with each other and, I don't know, have bad side effects. The 3rd one can be taken with anything. So I'm going to let you kind of see if you can figure out how to draw that one. And you are going to have 3 inputs. So you're having A, a B, and a C. Now, I'm going to start off with the one at the bottom of the page. I'm going to draw it and show you how you figure out all the combinations. And I'll do maybe 1 or 2 of those. And then on the homework, I still have to draw the ones for the homework, and I'll show you a couple of other things, and then maybe do one of each of those. Okay, So at the bottom of 178, we have actually one that's not really that complicated, but it does have 3 inputs. So we're going to have to figure out what to do with 3 inputs. So we're going to start with an AND. So this is A, and here we have B. Then we have a NAND, and there's a line from B down to this one. So whatever B is goes to this one as well as this one. And then we have a third one that's a C. Okay, then the output of this goes over here, and the output of the NAND gate goes up here, and then these go, that should be a curved line, an OR gate. And then we have the output. Now you notice in this one, I drew this line straight and then this one coming over and up. It doesn't matter whether you do that, or you could have them both coming over here and coming down toward the middle, or you could have this top one coming down and this one coming straight out. It doesn't really matter physically on the page where you put them. It's just that both of these input or outputs go to the input of that one. Okay, so now we have all these possibilities, and we need to get all the combinations of zeros and ones for A, B, and C. Well, here's the easy way to do this. We have A, B, C, and the output. If you think about starting with B and C, that's the 2 outputs or the 2 inputs that we've used before. We have a possibility of 0, 0, 0, 1, 1, 0, and 1, 1. And then for A, we can put 0 with all 4 of those. Now we can just repeat this and do 0, 0, 0, 1, 1, 0, 1, 1, and put a 1 out here in front of all 4 of these. That's the easiest way to get all the combinations, because just randomly trying to figure them out is not a good way. Okay, so let's look at maybe a couple of these. Let's do this second one. Okay, so we're going to start out with A is 0, so A is 0. B is 0, so we have a 0 here, and that comes down to here. And then C is 1, so here's a 1. So we go back to our gates. 0, 0 with AND is a 0. 0, 1 with a NAND is a 1. And then a 0, 1 with an OR, 0, 1 with an